Assalamu alaikum and good morning, all of you. Now, in my next lecture, I would like to describe you how is the generation of general representations of different functional groups of the organic chemistry from the alkyls we have generated already, even from the isomers when we discussed about in the simple example like butane as well as pentane. Now, furthermore, we can describe like this from hydrocarbons or single bond. Generally, we represent it as this is actually what's called as alkyl. But this or single bond means actually this can be CH3 single bond, this can be C2H5 single bond, this can be C3H7 single bond, this can be C4H9 single bond, C5H11 single bond, and these constitute condensed formulae. And similarly, these can be represented like this CH3 single bond, but here this can be CH3 single bond, CH2 single bond. This can be CH3, CH2, and CH2 single bond, and this can be CH3 single bond CH2, single bond CH2, single bond CH2, and single bond, and this can be CH3 single bond CH2, single bond CH2, single bond CH2, single bond CH2, and single bond 1, 2, 3, 4, and 5. That means this can be open structures. But these are all for alkyls, ALKYLS. But these alkyls can also be like this. For example, we have generated from the isomers. This is CH3, CH3, single bond CH and single bond, and this means isopropyl. And similarly, this can be CH3, single bond C, from upward CH3, from downward CH3, and single bond. This can be T-butyl. This is small t, and dash butyl means tertiary butyl. Tertiary butyl is containing a carbon atom without any hydrogen atoms, and this is having a single bond with it. That means this is T-butyl, and this is again any of the alkyls. This can also be CH3, CH3, CH. This is the isopropyl representation. Then after CH2 single bond, this can be called as isobutyl. And similarly, if we can proceed further like CH3, CH3, CH isopropyl, from here CH2, CH2, and single bond. As we increase the number of CH2 carbon atoms, this will become the total counting of the carbon atoms, and finally alkyl. That means isopropyl until this carbon is CH atom. Then after 3 carbons, 4 carbons, and 5 carbons, this will be called as isopentyl, isopentyl, and so on, and so on. And in general, you should understand now what we mean by these representations, these alkyls, and then after we will proceed for the general representations for different functional groups or the organic chemistry. We will proceed like this. This is hydrocarbons. Then after this is R single bond is generally alkyl. Let's suppose we will add H to this carbon atom, and this will become the general representation for, this will be called as for alkanes, ALKANES. And if we represent this like R single bond, and then we will join another R with this will become again the general representation for alkanes. These both are the general representations for alkanes. But if we represent R single bond, then we will add here CH double bond CH2. This will be another general representation. Then after, for example, R single bond CH double bond CH single bond R, this will become the another general representation for the same thing, and we will represent this like R and R, yani ki we will replace the hydrogen atoms. Then after C double bond C, R and R, these all will be the general representations, general representations for alkenes. ALK, we will add then ALKENES, means C double bond C is within these molecules. Then in the similar manner, then after we will proceed like this. For example, if we add R single bond with C single triple bond C H, and this will become the complete representation of another thing, and or this will be represented like R single bond C triple bond C single bond R, then we will replace this hydrogen atom by R, and these both will become the general representations for molecules ALK, YNES alkynes. YNES determines there should be carbon-carbon triple bond within anywhere in the molecule. Then after we will proceed further like this, but you have to remember all these things, and then we can proceed further in the discussion of the different organic compounds, such as we will represent R single bond, this is alkyl, then we will add it here X, where X is equal to fluorine, chlorine, bromine, iodine, etc., any of the halogen atoms. Like for example, if this will be R single bond Cl, means alkyl chloride. If it will be R single bond Br, this will be alkyl bromide. And in the similar manner, if this will become R single bond I, that is alkyl iodide. We are not including here astatine atom, because astatine is being a radioactive element whose lifespan is very small, and the fluorine atom forms the compound that are unstable, and therefore we don't discuss more much about fluorine or astatine. Now we have to proceed furthermore like this, such as we will add R single bond with OH atom, means group of atoms, that it will become the another representation for alcohols, AlCO, HOLS. It will become alcohols. That is discussion. Furthermore, we will introduce the IUPAC nomenclature or common naming system in the any of the general representations, and that will be observed later on classes. Like in the similar manner, we will represent the R single bond, and we will add this with C double bond O single bond H, and this will become aldehyde. In the similar manner, we will add R single bond C double bond O single bond OH, and this will become the general representation for carboxylic acids, and in the similar manner it will be added R single bond O single bond R, single bond O and single bond R, when we will add to this R single bond, and this will become the general representations for ETHERS, ethers. Here instead of R we can take this R single bond as, like for example benzene ring. For the aromatic compounds, benzene ring will be added with single bond OH. This will become phenols. And in the similar manner, if we will add benzene ring with this C double bond O single bond H, this will become benzaldehyde. In the similar manner, here for this carboxylic acid, when we add this benzene ring with C double bond O single bond OH, this will become benzene carboxylic acid. That is actually, this is the name in IUPAC system for carboxylic acids. This will be for ring compounds name given, will be given to the ring compounds like name of the ring, then add the carboxylic acid, that means benzene carboxylic acid. In the similar manner, if we add here instead of R, we will represent this by benzene ring single bond O single bond benzene ring, because R groups is represented by benzene ring, and this will become diphenyl. In the common system, we will discuss that thing in the furthermore nomenclature discussion. This will become diphenyl, and this is single bond O single bond R. This is the representation for ETHER, that means ether, diphenyl ether it will become. Then after we will proceed furthermore in the similar manner, like for example when we will represent R single bond with C double bond O single bond Cl, this will be called as ACYL CHLORIDE, acyl chloride, and this will be called as derivative of carboxylic acid, derivative of carboxylic acids. And this will become acyl chloride. In the similar manner, R single bond C double bond O single bond NH2, this will be called as alkanamide, AMIDE. This is another derivative of carboxylic acid. And if we add R single bond C top double bond O single bond O single bond R, and this will be the representation for ESTERS, esters. In the similar manner, if this will be represented as R single bond C top double bond O single bond C top double bond O single bond R, and this will be representation for, this is called as anhydrides, ANHYDRIDES, anhydrides. Then after, if we will represent R single bond NH2, this will be called as alkan or alkyl amine, AMINE. Then after we will proceed further here like this. For example, this will be R single bond C triple bond N, and this will be called as alkyl cyanide. If we will represent this R single bond R single bond N triple bond C, and this will be called as alkyl isocyanide. but the topmost bond here will be coordinate bond. There is actually a difference between the covalent bond system. Covalent bond is of two types. One covalent bond is that is bond formed by the sharing of electron pair or pairs between the atoms that are joining with each other, and but the electron particles are shared by both atoms. That will be called as normal covalent bond. But if the electron pair is shared by a single atom, but atoms will be attached different. For example, here in case of alkyl isocyanide, nitrogen is sharing both the electrons, but carbon is getting attached to this alkyl cyanide molecule with the nitrogen atom, and this is called as arrow-headed bond, and that's called as coordinate covalent bond. Coordinate covalent bond. That means when both the electrons shared that form bond are donated by only a single participant. Then furthermore, we will discuss the different discussions in the especially up to, I should say, up to higher class studies, different various of the what's called as discussions of the organic compounds, and that will come any of these representations, and that will be observed in the later on system, inshallah. Like for example, we will represent or we will observe somewhere benzene ring single bond N, double bond N, single bond Cl. This is called as benzene diazonium. Right. And these things you have to remember for the further observation when we discuss nomenclature or different physical or chemical reactions. These things you should remember, and inshallah you will understand each and every concept of organic chemistry up to almost I should say various classes or various entrance, various competitive exams levels, inshallah, and these things will be discussed inshallah furthermore in different classes. Good luck and goodbye. Khuda Hafiz.